Today we're doing 6.1. We are talking about nth roots and rational exponents. This is similar to what we were doing last unit, but when it says nth roots, that means that any number can be in this spot of the root. Do you guys remember, and I think you talked about this a little bit in Algebra 1, but for example, if there was a 3 here, what would that mean? You need 3 to make a group. So like if I had the cubed root of 27, 27 breaks down to what?
3.
Good, 3, 3, and 3. And so you would need all 3 of those to make a group to pull out. Where when you have square roots, it normally doesn't say a square root, but it's really, they have an imaginary 2 there. And so for that one, you just need 2 to make a group, right? So as a recap here, whatever number is with that little root, it'll be like right by the root sign, like inside this little root thingy. If it has a 3, you need 3 in order to make a group to pull out. So for instance, if I had the square root of 27, I thought I said it, but maybe I didn't.
I got it.
We're good? Okay, cool. Okay, now this is actually the tricky part, is what we're going to talk about right now, so I'm just a little scared. If A is less than 0, what numbers are less than 0? Negative numbers. Okay? There are no real roots, and the answer is in terms of I. And this is when we're dealing with n being even. Okay, what is an even number? Oh my goodness. 2, 4, 6, 8. Okay, and we're done with this pencil. Okay. Okay, so they were telling with 2, 4, 6, and 8. So that's what we were dealing with last unit. If we had a negative number under a root, it got pulled out and it was a I. Okay? Now, and remember that when you take the root, it's going to be plus or minus. Okay. Now, if n is an odd integer, okay, and a is less than 0, and numbers that are less than 0 are negative numbers, you actually get 1 real root as an answer, but the answer will be negative. So for example, if I took the cubed root of negative 27, see how this is an odd number? We know this breaks down to 3, 3, and 3, right? But this answer will end up being a negative 3. The reason is, if you think about this, negative 3 times negative 3 times negative 3, does that make negative 27?
Yes.
Yes. But that will only work with an odd root.
So if 4 through negative 27.
Then you would have an I. Okay? So even roots, you're going to get an I with a negative. Odd roots, you're going to just get a negative number. So odd roots are not going to have I's. Okay, so let's go through and try this. Okay, if you look back here, see how this says n and a? N is telling you your root number, and a is telling you the number under the root. Okay, so when I write this, this is going to be written as the 4th root of 625. Okay, Vienna, how many numbers do you think I'm going to need to make a group?
4.
Very good. Okay. 625, and you guys can use calculators, but 625 is 25 times 25, and then we know that 25 is 5 and 5, so I have exactly 4 of those, so my answer is 5. There's nothing outside here. Yeah, so you, in order to make a group, you need 4 of them, but all those, they make one group, so they just make 1 5. Okay? All right, so how am I going to write example 2? Okay, so I'm going to give you about 15 seconds to try this one on your board, on your own, and you can write it on a board or just show me on your papers. Good. Sorry. No. It is an odd root. Remember, odd roots, you get a, good. Odd roots, you'll get a negative answer, where even roots, you get an I. Good. Good. Right? There's no I, right? Okay. Good. Okay, 64 breaks down to 16 and 4, and 16 is 4 and 4. So I need 3 for a group, but because this is negative, these could actually each be negatives, because those all multiply to make a negative 64. This answer is negative 4. So again, anytime that you have an odd root and there's a negative inside, the answer just is going to be negative. If this had been a 2, then you would have had an I. So even roots, you get I's. Odd roots, you just get a negative. Yes, Vienna?
Do they put 2 here?
No. Normally, if it's a square root, you just see the root sign.
And then anything other than a
2, they will write it there.
with a negative, you don't bring it out. You just
Well, no. If it was 4, is 4 an even number?
Oh, we're talking about good. It's even. Oh, it's I. Okay.
Okay? All right, so evens, you get I's. Odds, you get negatives when you're dealing with negatives inside. Okay. Do we have other questions before I move on? All right, so you have radical notation. That's when you have a root. That's also called as a radical or root, versus rational exponent notation. Okay, exponent notation is dealing with exponents. Okay, an exponent's like this, 5 to the 2nd power. That 2 is a exponent. Okay, so we're changing it. Oh, look, I showed you there. There was my example. There's an exponent. 1/2 is the exponent there. So we're learning how to go back and forth, how you can write things in root form, and you can also write them in exponent form. So we're going to change this to root form. Okay, what you need to know when you're changing something to root form is that this bottom number right here represents your root number, and this 1 represents your power or exponent. And the number right here, that's the number that goes inside the root. So if I write this, I'm going to go ahead and write a square root. The big number, 5, goes inside. This 2, and if you want to, you can write the 2 just so you understand where it's going. This means that that's a 2. And then whatever this answer, it's raised to this number as a power. So then the 1 goes there. But normally, if you're raising something to the first power, you don't write it. And if it's a square root, you don't write it. Right? You don't have to write the 2. So this could also be written as just the square root of 5. But you need to understand this process here because it won't always be a 1 and 2 here. Okay? Are we ready to move forward? Questions? All right. So look at this one with the 5 and the 2 and 3. I want you to try to write it with like the roots and the exponents. Okay? I can't read it. I'm sorry. But you can show me your whiteboard or wait.
The answer will end up like number inside parentheses.
Yes. Yes. Close. That 3 though needs to be like in that root spot, like inside that. That should work. Okay. All right. Either you guys already have it or you're not even trying. I'm thinking it's not trying. So let's get back here to focus. So this number again is our root, and this number is our power. So when you're doing your root, make sure that number is in that root, because that's not a number in front of the root. It's just saying you're taking the cube's root. Okay? What number goes inside? 5. And whatever this answer was, you would end up raising it to the second power. Great. Okay, now this one we're going backwards. On example 5. We are going backwards. So how will I write this one? No, bless you. We want to raise it, we want to make it in exponent form instead of root form.
With the 5 next to it.
Because this is really being raised to the first. So this will be written as 5 to the 1/4 power.
Oh, that's how you say it.
Yes. Before I move forward, is there any questions? So let's have you try one more. If I had the cubed root of 2, how would you write that in exponent form? You try it first. I'm just going to give you about 10 seconds to try it on your own. Good, good. 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 All right, so this would be, I'm sure you got it, 2 to the 1/3 power. Thumbs up if you got it right, thumbs down if you got it wrong. Okay, good. All right, this says evaluate without using a calculator. So we need to change this into your root form. So 10 seconds for you to write this in root form. So if we're writing it in root form, you should write this,
First thing you said.
the square, what?
You had a 2 there earlier.
I just made up a problem here and had you try it on your own, if you're
I
with
didn't-
us.
Oh, I was doing that one. That's why I was like, why did I get that wrong?
Oh, yeah.
I was doing this one.
All right. So this should be, you should have written it as the square root of 4 to the 5th power. You always want to try to simplify your parentheses first. So can I simplify the square root of 4? What does it become? 2, because you get a pair of 2's. So that means I end up getting 2 to the 5th power. And then what is 2 to the 5th power? 32. Can somebody, thank you, Eric. Just say Altos Room student speaking. All right. Bye, Serena. You have the homework assignment. You can finish watching this online and hear yourself being called out of class. Okay. All right. So questions on example 6. All right. Moving on to example 7. On example 7, it says, hint, first make the exponent positive by changing the sides. Remember that you do not want negative exponents. In order to get rid of negative exponents, you can change it from one side to the other. Right now, if you write this as a fraction, this is the 9 to the negative 1/2 on the top over 1. So in order to get rid of this negative 1/2 exponent, we need to take all this and move it to the denominator. So I'd end up with 1 over 9 to the 1/2 power. So we can't work with negative exponents, so we always need to move them to make them positive. Okay? Now you're going to simplify that. So what am I going to do with 9 to the 1/2? What does 9 to the 1/2 make in roots?
1 over 30.
In roots. How do I write it? Thank you. The square root of 9. And do I have to write that 2 there? No. So if you want to, write it. If you don't want to, don't write it. And what is the square root of 9? Because we can't have roots in the denominator. We break it down, it becomes 3. So I don't have to get rid of the root. I get rid of it by just simplifying.
Why don't you have 2 there?
You can. You just don't have to write the 2, because if you don't write the 2, it automatically means there's a 2 there. 2 is the only one that will work.
The 3 and the 3.
Right. Oh, yeah, we can break it down with 3 and 3. Pair of 3's, which gave us that 3. Shh. Thank you. Okay, we're going to stop there and move on to the...